moved, my father would be outside filming, so like, oh, you're filming. I was falling on my face and
Yeah. All right. So we're going to get going with the notes today. Remember, this was kind of the more difficult day that you have to do your best to keep up with. And if you have questions as we go along, make sure to let me know. So the question for today is just a real quick one. This one's actually the same from regular physics. If you have a net force of 0, what is happening? What can you say for sure?
Motion continues even if it's 0.
Yes, I heard that said 3 or 4 different ways, but it's the same thing. Very good. So your motion will remain the same. If you're at rest, you stay at rest. If you're moving, you continue moving. The only thing you can say for sure is your velocity isn't changing. The same thing is true with torque. If you have a net torque of 0 for this section, you would say the same thing. You're not picking up speed or slowing down as you move in a circle. So we ended last time with that picture that you drew, and I'll be referencing that. Here's the next thing you need to draw. This is simply the forces that are acting on the graph on the picture that you drew last time.
So we don't have to leave any room in between the two pictures?
No. Leave some room underneath, obviously. We're going to be doing some work with them. But, yeah. Get this in your notes. And onward we will go.
It's really throwing me off on this one, so.
Mr. Hathaway, does the FWP stand for Fetty Wall?
Oh, yeah, I suppose I should say. FWP stands for the force of the wall on the pivot. Because in the picture that you drew before, there was a wall going up here, and there was a string coming down here holding this platform in place. The pivot would be right here. So this force is the force of the wall on the pivot. It's the overall direction that force would be going. Of course, the other force is tension force. Well, this seems easy enough so far, huh? So, FG6, the answer is yes. FG6 is the force of gravity of the person that's standing on the platform. FG2 is the actual gravity just from the platform itself.
There's a person standing on the platform?
Yes. You drew it yesterday. Yep.
You drew a person.
Yeah, but
So
The person would be standing like right here.
And there's a force of gravity.
what's
And here's
this
the
graph
mass of, like,
actually?
a board. And there's the gravity.
But why there are two angles?
Well, because one is for the string, and one is the angle of force that the pivot is experiencing here. Well, but if you think about it, you know, the wall is keeping this from flipping this way too. And so it has to have a force going opposite that as well. So, you got the force from the person. Fg2 is the force from the platform itself. It's coming down from the very middle, because that's the center of mass of the platform. So that's where those 4 forces are coming from. Questions on where they come from at all? Okay, onward.
Step 1, done.
What we want to do is we want to figure out basically everything that we don't know about this. And that includes the angle phi. It includes the force of the wall on the pivot. It also includes the tension force. So we've got 3 unknowns that we want to try and tackle and solve for here. Now the best way to start these questions, and if you want to label this, you can label it static equilibrium. They're basically difficult problems when things are holding still. It was probably the hardest thing that I had to do when I was in this class in college. Static equilibrium. I'll never forget that section. You're going to get it today. Why do we have to know it isn't moving?
Yeah.
Because otherwise we'd have to set our equations equal to something other than 0. So the fact that it is static and not moving allows us to actually be able to solve this. So the first thing we want to do for these types of problems is look at what's going on in the x and y direction. So, in the x direction, if I sum up all the forces acting horizontally, I've got the force. People at home. I've got the force of the wall on the pivot partially acting horizontally. So I would just call that FWPX, force of the wall on the pivot in the x direction.
Plus.
Rolls off the
So that's to the right. And then we've got tension to the left. So that's minus
Oh.
tension in the x direction. That'll be equal to 0. Now, of course, we need to be a bit more specific than this because I gave you a whole slew of numbers along with that picture yesterday. So let's make use of those.
One day.
So force of the wall on the pivot, we don't know anything about that. But if we're looking at the x direction here, that would be, the horizontal one here. So the adjacent side is going to be what? Sine or cosine? Cosine, yes. So FWP, cosine phi. That's fun
Okay,
to say.
so in this type of phi and phi, right?
Phi and theta.
Phi and theta. Sorry, people are saying giant talks. They're not related. Like it's not like a triangle where you can figure out like the different angles, right?
That is correct.
Just
Yep.
wanted to check.
Although that will come into play later
Okay,
for a different problem. So then we've got tension force here. And tension force is acting also horizontally. So that is the adjacent side, so we got to use cosine again.
53.
Yep. Cosine 53 degrees.
It was given.
It was given yesterday.
Yep.
On the top. This?
Monday. We did it on Monday.
It's
Yeah.
because we're finding
Oh, that's great.
Yeah, it's a continuation.
which we don't have.
We didn't talk about
I
it.
ran out of space. Oh, but I don't run out of space in this case. It's not.
Then we've got the y direction. Vertically.
Sine.
Sine, absolutely. And then we also have tension force going up, so that's going to be a plus. And that's going to be sine for the same reason. Now, opposing those two upward vertical forces is
Gravity.
gravity going down. Yeah, you're right. This should be 53. Thank you. Gravity going down. So that's FG6 and that's FG2. Or actually, I wanted to list this more generally first.
Oh, yeah.
I'm going to do that for the sake of the folks at home.
This is where I like when you do it the simple terms, but I don't think
Can we just keep the way it?
That's fine, yep.
we always skip it naturally, but
Minus FG6.
Yep.
And minus FG2.
Very good.
That's too much.
And now we have to make this so it's more specific.
wait, because F equals ma, we know the mass is an acceleration is 0, so
Calm down.
keep going.
Yeah, the equation is going to be equal to 0, and that'll come in handy. So yeah, FWP sine phi plus FT sine 53. Now here's the cool thing about force of gravity. I set the mass of the person equal to a certain value so that when you multiply it, the force of gravity ends up being 600.
Oh, man.
In general.
The mass was listed from the original picture you drew yesterday.
Wait, so
Yep.
what actually do you multiply? Because if
No,
F
I thought you
equals
said
ma,
20.4 kilogram at 61.2 kilogram.
Yeah, 20.4 times 9.8 is going to be equal to 200, and then the 61.2 times 9.8 is equal to 600.
Okay.
So that's where those numbers come from. Yes.
So would that be FWP sine phi plus FT sine theta minus M6G?
Yep.
Minus M2G?
Yes. Absolutely. So, look at this. We've gone as far as we can, and we still have two equations with three unknowns, and that sucks. So we have to look somewhere else. are you ready to look somewhere else?
No.
I'm ready.
No.
Good. Whether you're ready or not, we're going to do the same thing.
Okay, I might fall asleep, so someone just tell me this question.
Let's talk about
No,
torque.
I'm seriously considering falling asleep.
Also, say like
Now I
So,
half an hour.
in order to solve these questions, you need those equations about the x and y direction. In addition, you're going to need information about torque, and that's where we're going next here. Now, torque, again, next here.
Oh.
Torque-
I'm not gonna be here next year.
Torque is all about counterclockwise direction minus clockwise direction. So, it's, let's see here. We've got this going counterclockwise. Ft is going counterclockwise. So the torque T. And then we got to figure out what's going clockwise. Well, we've got force of gravity. The torque from, we'll say, G6.
Wait, I thought it's the opposite.
Gravity is.
Just a second.
Hypothetically, correct.
Write this down and I'll explain the discomfort.
How do you think that's the opposite?
I'm guessing, because, this way is counterclockwise. This way is clockwise.
Yeah.
So,
I really don't like drawing.
Okay, I can see how you get there. But what about the other force?
that's a good question. What about the force of the wall and the pivot? Why am I not taking that into account?
If you never count them.
Oh, because that's where the torque is happening?
Doesn't the book write?
Kind of.
Well,
That's what it makes it angle. So
That
that's
is the
why
focal point. Thank you, Seth. So torque is equal to radius times force. What's the radius here? 0, because you're at the 0 point. So the torque on the object at the pivot point does not matter. So we don't take it into account. So let's keep going with this and be more specific here. So in terms of these torque values, torque is equal to radius times force, but not just any force, it's equal to the perpendicular force of the particular spot. So for the tension force over there, it's going to be equal to tension force perpendicular times length, which is the full length of the platform, L. What's that?
I feel like you just felt like drawing a T and upside down T next to each other to do this.
What does that mean, perpendicular?
Yeah, perpendicular. Tension force perpendicular.
I just want to smush them together.
So for the force of gravity 6, that is right here. So that's going to be FG6, and that's automatically perpendicular, and that's times L6. And in addition to that, you've got force of gravity 2, because I think I did say L6. Yeah. And then we've got FG2, L2 equals 0.
Okay, so with the information you gave us before, we're not supposed to have L6. We just have L and L2, right?
No, there should be an L6 in there, unless I forgot to put it up. There it is? Okay, good.
But you just didn't write like how much of the distance is L6.
Oh, yeah, but you didn't give us a value.
You do you. All right. So again, we have to be more specific now, and that's going to be our next step. We got to be more specific about this. So in terms of the tension force perpendicular. So tension force over there. Perpendicular would be going up. That's the opposite side. So that's going to be sine of 53. So Ft sine 53 times the length minus force of gravity. That's just going to be 600 times the length L6, which is 2 meters. I'm going to leave units This is going to be long enough. And then we've got FG2, that's 200 times its length, which is 4. Yep.
So the first L should be 8. You just didn't write it right.
8?
Yeah, the LF, the force of tension sign 53.
You could, yeah, you could call it L subscript 8. On my notes, I just have regular L because it's the full length. But
Well, yeah, but I'm just saying in the
No,
equation
you
you don't
get
have,
the
you have L
value.
instead of 8.
oh, yeah, yeah.
Get the
Yep.
value out of it.
We'll get that number in there. Thank you.
Okay.
Now we're all set. Hey, look! One equation with one unknown.
Yay!
Finally!
Torque helps us to solve for things.
You just will puzzle.
And I'm not going to take the time to do all the math. But if you go ahead and you do that, isolating your tension force, you're going to get a tension force of 313 newtons. So we are a third of the way there. How about that?
Wait,
We're only a third way.
I kind of
Yeah.
Wait, what?
So we still have to solve for the force of the wall on the pivot, and we got to solve for the angle. So here's what we do.
And you're taking physics.
But you already know the.
We know the tension force, and that's going to help us.
You're gonna solve for angle.
Yeah, we're going to solve for angles. So let's look back at the force equation for the y direction, what we have. And what we're going to do is we're just going to plug in the tension force that we found to this equation from a little bit earlier.
But you still need two.
I know, we'll get there. So we'll have FWP times the sine of, is that 53 then?
No.
Nope, we don't have that. FWP times the sine of our angle plus, yep, tension force, which is 313.
Sine 53
Thank you.
minus 600 minus 200.
Awesome. So that's the y direction. We can also do this in the x direction. So the x direction looks like it's FWP cosine phi, yep.
313 plus 53 equals
Thank you. So that's where we're at. I know we've covered a lot of ground so far. Questions on where this came from?
You're not gonna combine those two together, are you?
Yes, we are. Everybody okay with where these numbers come from? We're just plugging 313 into the equations we developed earlier. So, you guys are going to love this. So, we've got two equations and two unknowns, which means mathematically we can figure them out. So, let's see here. What I'm going to do is I'm going to take this and I'm going to chuck it to the other side of the equation. And I'm also, I'm going to do the same thing for this. I'm going to chuck it to the other side of the equation.
They have a common value.
When you do that, here's what you end up with. Actually, I should change color here. Yeah.
invisible ink. Black light day.
We got to have one of those again, don't we?
We have one of
So
those.
I can show
I know.
Actually, no, it wouldn't really be that conventional because then the students on the recording would like
Oh yeah.
not be able to see it.
They can miss a day every here and there.
Yeah, we can just have a work day like Katie said.
When we have one of our worksheet days, we're not recording, we can do that.
So that's what you would find for the y direction. In the x direction, you'd have this. And those would be in newtons if you worked out the units.
Then you take off FWP.
Well, how are we going to do that, Potter?
Wow.
I was kind of hoping you would tell us.
So here's the thing. As long as we do the same thing to one side of the equation as the other,
You can add
we're cool. So here's my proposal. Ultimately, I'd like to get rid of the sine and the cosine into like one equation. And we can do that if we divide them. So as long as I'm consistent, we can do that. If I divide this side, it will be equal to the quotient of this side. Again, as long as you do the same thing mathematically to the left and the right, then you get the same proportion once it's finished. So once I do this, that goes away, just dividing.
That'll be tangent.
Sine and cosine
Tangent.
turn into
Inverse
tangent.
Inverse tangent.
Are you
The
confused why you can do it?
whatever the thing is, that's the
They're
end.
equal. So it's like, say, the top equation is 2 equal to 2. Then you're just doing the same thing. Or if you want to say the bottom's 2 equal to, then you're dividing both of the top.
So the top,
sides.
so the top equals the bottom.
No, you have a
What is
common. You have a common variable. You have a FWP. So if you divided both, the FWP would just get canceled, and which is left sine the angle divided by the cosine angle, and which is tangent, and you inverse that tangent, it will become the
There are
angle.
teachers out there. I'm not getting a detention for a gag.
Good idea.
Oh, man.
Everybody follow what Katie said here?
No, because
So,
if you have an equation, and then say you want to do anything to it, as long as you do the same thing to both sides, you're fine.
right.
So let's say you have another equation, 2 equals 2. That is true. It's the same number. If you divide each side of your original equation by 2, then you're fine. It's
Yeah,
the same
okay, I
equation.
see, I
The
see.
only difference is, instead of 2, we have much more complicated things, but they're still equal, so it's the same principle.
exactly. I hope the camera picked that up. Thank you very much.
Great job, Katie.
We're doing the same thing to the left and the right. That's what makes this legit. And so in the end, we end up with a tangent function, inverse tangent to isolate the angle, and you get 71.1 degrees.
So just put it back and solve.
Exactly. That's how we get the force of the wall on the pivot.
Just don't erase the blue yet.
I definitely
Right.
tried to set them equal to each other.
That's what I was.
Right.
I thought what you were gonna do was
Like, take out the zeros and set them equal.
no. I was
graphing
thinking.
both, calculate.
I don't even know what I was thinking. What I would have had to do would have taken so 4 times as long.
I would have used it.
Let me use my calculator.
So this is our equation for the forces in the x direction. All I'm doing is I'm taking my new angle that I found,
That's in my math.
and I'm just plugging it in right here.
No, the right.
And now you've got one equation with one unknown.
Yeah, we're going on a circle.
What are we doing in a circle?
Nothing. We're
No.
good. We're good.
My math is so good. My math is octangular.
The answer will be 581.53, I'm guessing.
Yes, yes.
That's right, yeah. We're not looking for the
I'm
answer.
like, how did you possibly get 580 whatever instead of 71?
That is not what I got.
Well, you did it.
No, I'm saying that.
Now you could actually plug this into the y equation too and get the same answer, but it's a little bit longer, so I just did the easier one. Because as you can tell, this whole class is about doing things easy.
Yeah, not like calculus.
Well, in context, I'm sure this is the easy way, but overall, I just wait until there's motion into it. Right. Just wait till we can't set it equal to 0.
Right. Okay.
It's all with rounding. So like if you don't round, you end up with 577.5.
You're
Okay.
just complaining that's not what you got when you're off by 5.
That's just fine.
Mr. Hathaway, I rounded it for 112.
112?
I think I rounded it.
That's quite a bit of rounding right there.
I guess when you're dealing with these numbers, like in this context, rounding does make a big difference.
I suppose, yeah.
Like, did you not run the angle?
The
Okay,
more
so,
you do to it, the more you come
so if you use all of his rounded things, like the 188 and the 71,
Yeah.
and then do all that, and not like the actual full equation, you end up with like 577. But if
Could be like a couple, yeah.
But if you then do it all over and then keep all the decimals, you end up with the right answer.
New problem.
Whoa. I think I'm all touched. I'm all problems. That was like 5 problems.
Or normal.
No, we got it. It's okay, guys.
That was like 5
Everything's
problems.
fine.
Mr. Hathaway, this is engineering class.
Then the answer should be 535.
This is a board of some kind.
That's when you all round it. You round
Just
everything.
remember, the answer only worth 1 point.
And
Process
then
worth
Yep.
like 20 points. So even if you get the answer wrong, you just get 1 point off.
Like, that's
See if we can plow through this by the end of the hour. I am pretty confident that we can do so. This goes in your notes then.
I am not.
Oh.
Thank you.
we have no doubts.
So the whole idea behind this problem is to find out the minimum. We've got to find out the angle at which, if it is any smaller, this object will start to slip. Because if you go far enough down, it's just going to slide over. But we want to figure out exactly what that angle is. What's the minimum angle before this object starts to slip?
Oh,
So,
So,
let's do some force diagrams.
very difficult.
I don't know, I think it's more like 34 degrees.
hey,
Here you
I said
go.
At least 16. Hypothetically.
What is this?
That was fun!
Sure is.
You know, Mr. Hathaway.
Yes.
So you see. Can I still get my money back?
I really want somebody to just walk
You know,
away.
Question says,
Classical will.
was Trevor really the smartest one in this
Hi, Connor.
class?
100%.
Some guys, somebody had to do it.
100%.
All shall be clear
Mr. Hathaway, you need it.
one day.
Every other class except.
No, this all makes sense.
Yo, I'm doing this all on an outside
This is
stuff.
fine.
You should just one day, just by mistake, that show all the physics kids that this is what we learned in physics today.
Yeah.
Just start teaching them what we learned and just don't mention anything. Just go through an entire lesson.
And they'll be like,
Just act like it's what they're supposed to know.
I did accidentally, a couple days ago, I gave them the AP physics question instead of the regular physics one. They didn't say
What were they
anything.
gonna say?
They didn't say anything till I figured it out myself.
They're like, oh, this is so easy.
They're good
They're
sports.
just still doing their real slow.
Well, I mean, I saw it, before they wrote down too much, but they definitely started writing before I figured it out.
Nobody
Okay.
goes, wait a minute.
I'm not
everyone's
gonna
like,
lie.
I know what this is.
When you're doing the the questions, you kind of just write it down, and you're like, if I don't know this, there's probably a reason I don't know it. Type of thing.
Well, that's what I do most days. I wait for
That's
someone
true.
smart to speak. Or to shut up.
This one isn't as bad as the last one.
It looks pretty bad.
Yeah, I know.
No, it's actually okay. Once
Like,
I
How
actually
did that one
looked
virtual-
at it and said,
that
oh
one
yeah, I
virtual
know
day
those
we had,
things.
it was like a swinging pendulum.
What's
and it
the-
took us like, you know what I'm talking about or no?
No, I remember that. I remember recording
In
that.
regular
find it.
physics?
I'm gonna
In
find
regular
it.
physics? Or in this?
I thought about, was that regular physics?
Well, that's like the last lesson we learned in regular
This
physics.
picture right
I
here.
thought you were talking about the pendulum from the video thing from, like, Thanksgiving.
Yeah.
Oh.
Yeah, that one, okay.
That was
That
terrible.
was this class.
I didn't do that.
Well, only controls so many things. Let's talk about this picture.
Let's control physics. Let's make physics all sunshine and rain.
You know, if there's one thing I can control, it's time.
So, this is our board here. Hey, look at this. There's an equilibrium point. That's the spot at the very bottom. There's no torque there, so all this is going to go away.
Zero.
Woohoo! Now, the wall is providing a force straight over to the left. Now, because this question is asking about this particular angle, when I start to figure out the angle up here, from the force of the wall that's acting perpendicular, automatically you think, well, it's force of the wall times the cosine of phi because it's the adjacent side. And you'd be correct. But the thing is, we're not dealing with phi here. We need to figure things out about theta. So this is an example where this angle and this angle are exactly offset. And so what that means is cosine of phi is equal to sine of theta. That's where this is, where this comes in. This is the force acting perpendicular to the wall. That's where this comes from.
That's because we're dealing with the triangles.
Yes. Down here for force of gravity, gravity's going straight down, so the force that's acting perpendicular to that is this guy right here, right in line with the board, perpendicular to it. So because it's the adjacent side of the angle, it's Fg cosine theta. Questions?
Wait. No. No. How do you get FG cosine?
So if this is Fg, that's like the hypotenuse of your triangle. And this right here, that arrow, represents the portion of that gravity that's acting perpendicular to the board. And so it's the adjacent side of this angle here. And because it's the adjacent side, we got to use a cosine function for that. Just like on sine functions, we use the opposite side. And so that's where the cosine comes from, Fg cosine theta. That's the adjacent side of your hypotenuse, and that's the portion that's acting perpendicular. Other questions? Okay, let's see how far we get. I don't know if we'll finish it, but we'll do the best we can.
The angle.
I don't know, we had a calc quiz today, and there was 5 minutes left, and I was on number, 10, and there was 16 questions.
Oh, yeah?
Yeah.
Nice.
And I was in the quiz section.
Favorite part of the cat stuff, 'cause
It always sounds like there's something.
it's so much fun.
Here's the equation in the x direction. You've got the force of the wall to the left, you've got force of static friction to the right, and that's it. Yahoo! That's equal to 0.
Yahoo!
Now we can say a couple other things about this too. Force of the wall. This is not a continuation of this equation. This is just extra information. I'll put it in blue.
The gravity would be lower.
I'm just barely processing it, so don't throw me in
Well,
space.
the funny part is I'm already not processing.
Huh?
You're being
Yeah, but
gravity,
you
therefore nothing would happen.
All right.
You need
I don't understand what you teach until after a week. So right now I'm just copying it.
Well, I'm glad it eventually sinks in. So force of the wall is equal to force of static friction, and static friction is just normal force times coefficient of friction. And in this case, normal force is just mg because it's just sitting there. In terms of the vertical stuff, we have a normal force up, we've got gravity down, and that's all there is to that. In other words, normal force equals force of gravity, which equals good. Question so far?
I legitimately feel like I'm about to.
Please don't.
But do you want me to grab Mr. Hathaway's garbage?
Well, yeah, you can't throw up in the recycling bin.
Well, you can't throw it.
On to torque. Let's keep going, guys. Let's keep focusing
You
here.
ever notice that the recycling bin outside is recycled?
So, we got to do the torque for everything going counterclockwise minus everything going clockwise. So counterclockwise is going to be the wall. Clockwise is going to be gravity. Why? Because counterclockwise would be like this direction, and that's the direction that the wall is trying to, is pushing.
Oh, okay.
And gravity's trying to make it go clockwise. So,
Well, why gravity?
because it's pulling it down, if gravity would win this battle, it would go like this. And that's clockwise.
Oh, okay.
Yep. So let's just,
Gravity is winning this after all.
well, I mean, it's at rest right now. the goal is to figure out the minimum angle before it starts to
Okay.
slip.
Okay. That makes
So, let's do this. Force of the wall times sine theta. And the reason we're doing sine theta once again is because this is the portion of the force of the wall that's acting perpendicular. And that perpendicular force is the force we must consider when we're dealing with torque. And that's multiplied by the length of the whole thing, L. And it's going to go away.
Bye.
Over here.
Bye.
Then you flip it the other way.
And then in terms of what's going on with gravity, we've got Fg cosine theta for the reason that we talked about before as to why that's the perpendicular force and all that. And we're going to multiply this by its length. Its length is going to be L over 2. Because if you average the position of that entire board, the average would be the very middle of it. So that would be length divided by 2. That's equal to 0. Questions so far?
I have a lot of questions, but I'm not going to ask.
Okay.
I have a question.
Yes.
Is torque like directionless, or I don't understand that? Because is there no X, Y, or how does that work?
Well, torque has a direction based on the right-hand rule. We can review that
It's
another
on
time.
I
But yeah.
understand the screwdriver rule.
Yes.
The lighter rule.
There we go. So, let's see if we can figure out the angle from this.
Screwdriver. I don't know why I said screwdriver, but the lighter. I know what you
Sine theta times L. And I'm going to move this whole thing to the other side.
Wait, but we don't have, we only have one number?
Yes.
Oh, are you kidding me, dude?
Nope.
Oh, okay. As long as you're not saying that.
Fine.
Yeah. Trust me.
Got
I
this.
trust you, but I don't trust physics.
So let's see here. My goal is to get this angle all by itself. So if I want to do that, these are on opposite sides. I'm going to cross out the lengths because they get rid of each other. What I'm going to do next is get rid of, having two trig functions. So I'm going to divide both sides by cosine. Why would I want to do that?
That'll be tangent.
Yeah.
Or cotangent if you want to.
And that's equal to Fg then
1/2.
times L times 1/2, yes. So that's where we're at. So now we need to solve for our angle.
Oh,
So we're going to divide both sides by Fw.
Oh, so you just get
Yeah, you're seeing this. Good.
aha.
I wish I had it.
And since Fw is equal to Fg,
Absolutely. You guys are seeing this through already.
no, Fw is not equal to Fg. Never mind.
You just said absolutely, like you're correct, and then you just like.
Then you said no.
Okay.
Did you say FG over 2FW?
Yes.
Oh, I know what it is now.
Inverse tangent.
Mg cancels out.
Yep.
So then you're left with
The
1/2
friction.
over 1.
The static.
So Fg over 2Fw. And the next thing we're going to do here is put the proper variables in. Fg is equal to mg. Fw is equal to mu s mg. And look at that. Goodbye, mg. We hardly knew you. I better change you a different color.
Gee.
So then you get. Okay, I think I.
All right, so in the end, our angle is equal to the inverse tangent
1 divided by
2 times our coefficient, which is 0.4.
0.8.
And when you do that on your calculator in degree mode, you're going to get an angle of 51.3 degrees.
Yee!
Problem
No,
solved.
that's 1/4. You're wrong.
Well,
Yeah.
3/4.
Seven
Wait,
1/4.
3/4.
problem solved.
Woo! Okay.
Good afternoon, everybody. Welcome to the end of this beautiful day here together.
Thank you for sticking with me.
Hey,